Hey everyone, welcome to the start of our kinematic series. We'll begin with motion along a straight line, also called one-dimensional motion. We will try to see and understand the key parameters, because they are the ones that lets us describe motion. The key parameters include position, distance, displacement, speed and velocity, and lastly, acceleration. To make it clear, we will use visual examples, and I hope you'll enjoy it.
Let's discuss motion, one of the most fundamental concepts in physics. Motion is simply the continuous change in an object position over time. In physics, we generally classify motion into three main types. The first one is translational motion, where the object moves along a path. For example, a train traveling along a track. The second one is rotational motion, where the object spins around an axis, like a ceiling fan. Finally, the third one is vibrational motion, which is a back and forth motion. For example, a pendulum swinging. For this chapter, we will focus only on translational motion, and more specifically on one-dimensional motion, meaning motion along a straight line. Let's talk about kinematics and dynamics, two important branches of mechanics. Kinematics is the part of mechanics that tells us how object moves. It deals with things like position, velocity, and acceleration, but it doesn't concern itself with what causes the motion. On the other hand, dynamics is the branch that explains why objects move. It studies the forces and interactions that produce or change motion. Here is a simple example to make this clearer. Imagine dropping a ball from a balcony. From a kinematics perspective, we just describe the motion as follows. The ball starts with a horizontal velocity, falls straight down, speeds up, and hits the ground in about 2 seconds. From a dynamics perspective, we explain the cause. Like, the ball falls because gravity pulls it downward, producing acceleration. So remember, kinematics is how motion happens and dynamics is why motion happens.
Now let's talk about parameters. A parameter is just a number or quantity that helps us describe or measure something, which in our case is motion. Some of the main parameters we use are
position, which is about where the object is, distance, which is about how much ground the object has covered, displacement, which is about the change in position considering direction, speed, which is about how fast the object is moving while ignoring direction, velocity, which is simply speed with direction, and finally acceleration, which is about how much the velocity changes over time.
We use this to really understand how an object moves along a straight line. In this video, we will cover a few of these parameters, and in the next video, we will continue with the rest.
Let's start with position, one of the most basic parameters in motion. The position of a particle, usually written as x, tells us where the particle is relative to a reference point, which we call the origin. If we know the position at all times, we know the particle's motion completely. A reference point is a fixed place or object used to determine position in motion. In short, it is the mark to judge motion or location. A reference frame is essential in a sense that without a reference, we cannot define the position. And with reference, we can specify position along the line. Now let's try to use an example to visualize this. Imagine a line on the screen and a dot moving along it. If we do not have any reference frame, we cannot say where the dot is.
Next, we introduce a reference frame, in our case a point on the line. Now we can say the dot is 3 meters to the right of the reference point. With this reference, the position is defined and we can start measuring motion.
We also often use the particle model to simplify things. That means we can represent an entire object by a single point, like using the center of a rectangle to describe the rectangle's motion. Now that we know position, let's talk about distance and displacement, two closely related but different concepts. Displacement, usually written as delta x, is the change in position of an object over a time interval. Mathematically, Delta x equals the final position minus the initial position. It's a vector quantity, which means it has both magnitude and direction. If the object moves to the right, displacement is positive, and if it moves to the left, it's negative. Distance, on the other hand, is the total length of the path traveled. It's a scalar quantity, so it doesn't care about direction. It's always positive. Importantly, the magnitude of displacement can never be greater than the distance. Now let's look at an example that makes things obvious. Imagine a ball rolling back and forth along the x-axis. At the start, the ball is 3 meters to the right of the origin, point A, and we track its center position every 2 seconds. So initially, the ball was 3 meters to the right of the origin, that is point A. At the second, it is at 5 meters, point B. At the 4th second, it is at 4 meters, point C. At the 6th second, it is back at the origin, point D. Then it goes further left, minus 2 meters at point E and minus 4 meters at point F. Now let's calculate displacement. Displacement, or delta x, is the change in position. For displacement, we only care about the starting and ending positions. The ball begins at 3 meters, point A, and ended at minus 4 meters, point F. So, delta x equals final position minus initial position, which equals minus 4 minus 3, which equals minus 7 meters. Meaning the ball ended up 7 meters to the left of where it started. To calculate the distance, let's add it up piece by piece. From A at 3 meters to B at 5 meters, the ball traveled 2 meters to the right. That is our first distance segment, 2 meters. Next, from B at 5 meters back to C at 4 meters, it rolled 1 meter to the left. Add that, 2 plus 1. Then from C at 4 meters all the way to D at 0, it covered 4 meters to the left. From D at the origin to E at minus 2 meters, it traveled another 2 meters left. Finally, from E at minus 2 meters to F at minus 4 meters, it rolled 2 meters left. Add all that and the total becomes 11 meters. I think this makes the difference clear. Displacement cares only about where you ended up. Distance cares about how much ground you have covered. Also notice displacement is a vector, magnitude plus direction, while distance is a scalar, magnitude only. That's it for today. In our next video, we will continue exploring these motion parameters. We will go into speed and velocity and discuss more details that will help you fully understand motion in one dimension. If there is anything in today's video you think we could improve or explain better, drop a comment below. I would love to hear from you. And if you enjoyed this video, don't forget to like, share and subscribe so you don't miss the next one. See you there.